All right, so if you go to overleaf.com and create an account, you're going to be able to do what I'm doing here. And the advantage going to Overleaf is you don't have to do all the installs that you would need to do on your own computer. Now, you can do everything I'm doing here on your own computer with those systems, but this is going to make it a little bit simpler to work, simply because everything I'm doing, you can do exactly the same way. The buttons are in exactly the same place. Nothing is different whatsoever. I already have an account, so I'm giving you a second to create your account on overleaf.com. So I'm logged in already, and I'm going to hope that you've gotten accounts up and working already. Okay, there'll be a little bit of a delay here. Anybody still working on getting that account going? Okay, keep going. Of course, I just slowed you down typing by making you raise your hand. You're in? You're in? Everybody's in? All right, so if you go into overleaf.com, you can actually go and you can create a new project. So that's what we're going to do. We're all going to create a new project. Once we create a new project, I'm going to walk you through the process of what this is and why we're doing it, but sometimes you have to schedule time for the computer to sit and to think. So if we look through create new project and you go down to thesis, you'll see something I spent a little time here just in the past couple of days doing, and that's uploading the Wright State thesis template onto here. So this will actually make sure that you're following the Wright State format right from the get-go. How do we find this in here? Heck, I don't know. I haven't found it in here yet. Let's see. Keep scrolling around. So if you scroll down to the bottom of this page here, Gallery Thesis. Those of you watching at home, I apologize if you fell asleep. Wake up, wake up. All right. So we can then do a search under Wright and Wright State Thesis. Now what you're going to see is somebody else put one up here already. This one, if you click on it, you're going to see is not the right one. And it's somebody put this up generously, but it's actually very, very pithy. It's not as broad as mine. And that one was just, they got there before I did. Mine is actually formally out there on GitHub. Okay, so we can go over here to Wright State University thesis template. Where is it? I'm having a lot of luck here. I wonder if they changed the, yep, this is it right there. Okay, so Wright State University templates. If you found that, it should look like this if you put your cursor over it, Wright State University thesis and dissertation template. Now, this isn't the only way to get this thesis template. Okay, this isn't the only way to get this thesis template. I'm going to give you another way to get this template. But if you do this, you can select this and you can add this. But you'll notice here, the title is a little bit corny. Now, this is hidden right here. It has some nice words on here, but underneath, if you can look, it says some really great title that provides a concise view of the topic your thesis will address. So I try to give you something a little bit interesting and entertaining, but makes it clear you should replace it. So throughout the document, you'll see strange things. Why would you put this in a thesis? Well, of course you wouldn't. It's meant for you to edit and change those things out. Now, if you're going to use your own editor, instead what you're going to want to do is go to github.com. And when you go to github.com, it's not going to look exactly the same, but then you can look for WSU thesis template, all run together, no spaces, no nothing. All right, if you go to github.com, and this is on video, so if you don't get this now, you can get this later. If you click on that, you can actually simply download this, and that will be a folder that you can write your thesis inside of directly. Okay, so that makes it easy either way. All right, so those are two different ways to get access to it. This is the way that you might actually end up preferring, but for teaching a class today, it's nice that everybody has exactly the same buttons. So why would you want to write your thesis in LaTeX or dissertation in LaTeX versus using Microsoft Word? Well, I'm going to give you a little bit of an argument that's somewhat different and misses the details of why, because sometimes you really don't know why to do something until you've done it, and then you say, aha. So why would you want to do this? Major journals when they publish those journals, they convert whatever you send in to LaTeX. It tells you there's something there. Okay? Mathematicians, scientists, engineers throughout the world use it. There's no advertising budget for it. It is open source, it is free, it has been around forever, it's stable. It runs on any platform. And when I say any platform, far beyond anything that you can imagine. Why? Because somebody owns an Amiga. Anybody remember Commodore Amigas? It runs on Commodore Amiga. It runs on everything. The point being that you don't have to rely on your document being dependent on whatever system you're on. So if you end up working in a computer lab someplace and all you have is Linux, you can use LaTeX. You can't use Microsoft Word. Okay, so it gives you that flexibility. Beyond that, over the years, what you find out is the compatibility of old LaTeX documents stands. It lasts, it passes the test of time. Microsoft Word documents start to falter, and I'll show you why. There's a little lack of comfort for people starting out with it, but you'll see, I see why this is going to actually last. And that's because, does anybody know the structure inside a Microsoft Word document in that binary file? You don't. Now, it is open, and you can look it up. But it's very, very complicated and convoluted. When you look in a LaTeX document, I'm going to show you the LaTeX document, and you're going to say, oh, I can read that. You won't know how to do that, and I'm going to tell you and explain it as we work our way through. But you'll understand it. So the advantage is that in 20 years, you'll open this document. Microsoft Word version 2030 is out or something like that. Your documents are incompatible. This happens. This happened to me. Okay, I can't open my old documents. I have a 20-year-old laptop in my office that I use every once in a while to open up old documents. It's a little bit ridiculous. But LaTeX documents that are 30, 40 years old, you can still read them. Why? LaTeX is actually raw text. Originally ASCII, you familiar with what ASCII is? It's a raw text file. There's no meta information underneath there. It's all right in your face. Now they use UTF-8 as well, which allows international characters. Okay, that's to say newer, that's really not all that new. That's been there for 15 years. What that means is that you can use almost any, actually you can use any text editor in the world to edit it, including Microsoft Word. So when you use LaTeX, you don't want to think about, I'm using LaTeX as an editor. What you're doing is using LaTeX as a file format, as a document. That is your document. With Microsoft Word, you think about using the application. But here you think about using the document, and you can edit it in dozens of different editors. Hundreds in reality, but there's only dozens it would be worthwhile. Those are actually listed on the GitHub website that I have for the thesis, and if we scroll down, you'll actually see that I give a lot of information on how to write a thesis in LaTeX. And here I say you're likely using Word because that's all you've ever known. The one thing I'm going to point out here is the reason you all use Word, is that because you made a decision or because that's what you were shown? The reason I speak English is because that's what I was born into. It wasn't necessarily a choice, and it wasn't necessarily even a good choice. I can spell better in Spanish than I can in English. But that's the reason I have that. With this, you have an opportunity to make a decision. So you should be conscious that you were brought in with a bias. One link I have here that we won't have time to do is looking at archiving data. This is essential, though, for your thesis. If we do have a few minutes, I'll go through that. But how to archive your data so that you can use it yourself when you're writing your thesis as you're moving along is really important. It's really important as a professional. And this is actually my most active blog essay that I've written. It's one that gets hits from around the world, and I've become something of a a hidden celebrity amongst librarians and such, because you want your data to survive. And if people can't get to the data, then you didn't do anything. So once your data is unreadable, it's gone. So you need to find a way to store it, archive it, and display it in a way that's meaningful. So keep that in mind. Another thing is when you're plotting, most of the time, you're going to want to use vector graphics. Okay, vector graphics mean I draw a line from this point to that point. You don't want to use pixelized graphics, okay, or GIF, JPEG, PNG, those are fine. JPEG means photo. If it's not a photo, don't use JPEG. It uses wavelet compression and smears it. Okay? It makes it look really, really messy. When you have plots, it really means there's a line from here to here, it's this thick. There's a circle, there's a shape. If you use vector graphics, it actually redraws that. And there's a dozen different formats for vector graphics that are out there. SVG, scaled vector graphics, being the most modern one right now. But you're all probably familiar with PDF. That's another one. Before that was encapsulated PostScript, encapsulated PostScript 2, Windows Meta Format, and Enhanced Meta Format. They can also do this. That's a Microsoft version of those. So there's a number of those out there. Unless you have a photo, don't use JPEG. Just don't use it. Don't use PNG. Don't use GIF. Or GIF, as you call it. Those do not help you. They actually cause problems. If there's no option, then you go in those directions. But always try to use a vector graphic. It's going to be the right bias. And as you start to do this, you'll actually learn this. The other advantage is if you use a vector graphic, you can edit the raw text inside that file because it's raw text, and you can actually retrieve your data because it's embedded in there. You don't want to do it, but you can. It's inside there, and I've had to do that before, because it's all written down as an actual plot. Okay, so I have a bunch of other things here on how to learn how to use LaTeX, because you're not going to walk out of here, hey, I'm ready to go. You'll actually be pretty close, surprisingly. But when you get out and you try to do some different things in a document, the one downside with LaTeX is you actually have to learn how to do things. In Microsoft Word, you don't have to learn it. You just have to find it. Somewhere there's a button to do it. Okay? And usually the buttons you find aren't doing exactly what you want, but you have to accept what Microsoft tells you that button is going to do for you. With LaTeX, it's actually a little bit closer to what you want to do, but it's harder to figure out exactly what it is because you actually have to use commands. Platform-specific advice. Windows, this is what I prefer right now for my usage, is I tend to use JabRef when I'm on Windows. You can actually use that on Unix, Linux, or on Mac OS. You can use MikTeX or TechLive. I really don't know which one. I've used either one. MikTeX, I think, is a little bit easier to use. Text Studio is an editor that I have installed. I actually use that on my Mac. Those of you using Macs, I apologize. I didn't update my website to say that, but I actually use Text Studio a lot. And I gave this presentation last year using Text Studio. Okay, so that presentation is actually on YouTube, so you can go see that in a little bit cloudier resolution. GoScript, and I have links for all of these. Why GoScript? Well, this allows you to take EPS, PDFs, convert them to different formats. It's relatively freeware. That's not completely true, but the reality is you don't have to pay for it. So that's what usually sells people on using that. Either that, or you can go out and get Adobe Acrobat and pay to convert your files. There's freeware for doing this. One of the keys you're going to see, I don't like to use applications where if I have my data or my documents, I need to pay somebody to unlock them. If I have Microsoft Word documents, if I don't have Microsoft Word at home, say I'm out of a job for 6 months, I can't read my Word documents at home unless I buy Microsoft Word. That's not an issue for me. I can get into all of my documents. Now, there are other open source versions for that. They don't work equivalently, but close enough. So it's not as big a deal as it used to be. But with LaTeX, you own it all. Doesn't matter. Any place. Licensing issues, doesn't matter. You get in the workplace, well, we only have 5 MATLAB licenses. Python, installed any place. So open source really, really helps. You got to know if you have to, you use the commercial stuff, but be very, very careful about that because it will bite you. And some of you will get away with it, but others of you will really get nailed by this. This is something I hear from a lot of our graduates and our students. So Mac users, I just have a wiki out there that I wrote back in 2000. Why did I do that? Well, what I did is I posted my notes on a wiki and everybody else edits my notes for me. I get credit and they keep my notes up to date for me. It's kind of a cool little technique. And it's the same reason I have a blog. If I document what I know and I'm wrong, somebody will point it out. Believe me, people on the internet like to tell you you're wrong. So I get better notes that way. And I read my own blog so I can remember how to do things. Cloud-based tools. Today we're going to be using Overleaf. There's a couple of others. LaTeX and Overleaf have actually merged. They're not done with that merger yet, but they are indeed the same company. And I don't know where that's going to go. I would just go to Overleaf at this particular point. And Zotero is actually .com, but it's open source. It's a little bit complicated that way. That's another tool that you can use for managing bibliographic databases. Yet again, if I have time, I will try to do that. This is something I'm going to try to make some of these notes out there and available. And if I have a chance during the semester, I'll put those out there and you can watch those videos as well. The nice thing about this stuff being all freeware and the format being easy, you can read and you can see what's going on. We'll show that. Graphical user interfaces. Now you can actually edit LaTeX documents in a graphical user interface that makes you a little bit more comfortable. So if you get too terrified of the commands inside LaTeX, don't be ashamed. That happens. Some people just really can't stand that. I know some people that are coders that use this. And there's a program called Lix, and it looks much more like Microsoft Word with menus. What you do find when you look at what's underneath in the LaTeX document, you'll see exactly the same thing you've seen in Word documents where halfway through a sentence, the font changed. The font size changed. Some weird thing changed. That does happen very easily. If you do use Word, make sure you use the concepts of this class, which is to use styles religiously. Don't try to change how a document looks at the local level. Try to change it globally. Define styles for headers, heading 1, header 2, header 3, title, paragraph, and then change all paragraphs. Okay? Don't go and say, well, this paragraph, I'm going to move it here. That one, I'm going to move there. If somebody says, well, the fonts need to change throughout this, you're in trouble. You submit it to a journal, you're in trouble. Spell checking, there are tools for that. You've got this, of course, it's built into Microsoft Word, but people don't know exactly how to do this in LaTeX because it is a little bit like a programming language. It's something like HTML, it's a markup language. And those exist, so they'll parse and they'll filter that. When we do this online, Overleaf has it built in online, which is very, very nice. Checking grammar, language tool. This one's a little bit harder to do. It's not built into Overleaf for whatever reason, I don't know. But if you take language tool and you install it, you can actually use it with what I've started to like, which is Text Studio. This is the reason I've started to use Text Studio. The one thing that I can tell you is when you're writing documents and you write them to me, some of you are going to go on, get PhDs, apply for jobs. I read a lot of resumes. And when I see typos and errors in there, it really pops out to me as a lack of attention to detail. And when you see those things, it creates an impression. No matter what you see underneath that, unfortunately, we see those things and that brings a bias. You don't want that bias against you, there's a lack of detail. The fact that you're all engineers means that you actually probably don't really care much about that type of detail and making it look good. You like functionality. I like functionality as well. But we all notice if there's a beautiful wall and one brick is crooked, you notice the one brick. You don't recognize the rest of it. So you have to be very, very careful with your documents. It really does end up mattering. I hate it too. So all the tools that I can pull, spell checking, grammar checking, all of those things, they all help to compensate for what is our shortcoming as engineers, is we often don't really care about those esoterics. All right, so graphical user interfaces we talked about, spell checking and grammar, and then making presentations in LaTeX. I'm going to skip that and go on. But this here, you can search, and in fact here, I'll hold this for just a moment. You can see the URL at the top. You'll be able to catch that in the video in case you missed it. All right, I'm going to actually close that window out. We're going to go over here, and I'm going to select this template if we still have that tab open. So when I do that, I have, well, I can see what's going on, and I'm going to open this as a template. I have to thank the people at Overleaf because I requested this become an official template at 9:30 this morning, and it just went on. It took about an hour for this to go on. And that actually is interesting. This is mostly freeware, but they will charge for high-end services. I challenge any of you to reach out to Microsoft and tell them you'd like them to do something. Good luck, okay? Call Apple and try to get them to do something, okay? It's really not going to happen. The neat thing about the open source community that I didn't say before is that there is a team spirit. We're all in it together. If you have a bug in MATLAB, like I found, I submit a bug report. 6 months later, they got back to me with a fix. Humorously, it was the fix that I submitted with the bug report. So in 6 months, they didn't solve the problem, but they were able to address it by telling me to do what I was doing already. On the other hand, with other languages, LaTeX, Python, their email lists, you go out there, you post, there are people that are just hanging out there. Hey, I'm going to take a little break from work. They're out there. They see a post. They're willing to help you. Why? You're not making money. They're not making money. It's a team effort. So it's actually like having a whole bunch of people working with you that you don't know around the world. All right, so this is a LaTeX document. Right here, what's highlighted in blue is comments. I had to find that out by looking just now because I don't remember what the color is. But the percent sign in the front is similar for those who use MATLAB. That's the comment symbol in LaTeX. The solid lines are just to make it look nice. This template was actually taken from a thesis of my student, updated by another student, and I said, you know what, I'm just going to maintain this because it makes it easier for all of my own students, and hopefully it's helpful to you. Now there's a whole bunch of stuff up here that you're going to actually ignore. And the reason you're going to ignore that is you don't actually need to know what it all does. Okay? It's stuff that makes it look right. You can look into it if you want, or you can ignore it. That's all up to you. But this is actually the kind of thing that's embedded in your Word document, but you just don't know what it is because it's linked to some C library or something like that, and you can't compile Word, so even if it's missing, if that C DLL goes away, Microsoft Word breaks, who knows what's going on. Over here, you can actually look at this, and if you get an error that there is no such package book tabs, you know you need to install the package book tabs. And you can Google, and it's pretty easy on every system to learn how to install the package that's called book tabs. But book tabs is for making tables. I don't even know what all these are, to be honest. I can't remember, but they're used. They're all used inside here. I probably should put a note here. Listings, I know, is for listing computer code and making it look pretty. All right, so over here is the code, and over here is the result. Okay, and the neat thing about Overleaf is it actually creates the result while you're editing the document. Most of the other applications don't do that. They only compile when you want to. The reason is somewhat historical. It used to take a lot longer to do that. What LaTeX actually does is a lot more processing than actually Word does. So it takes longer, which is why it doesn't work as fast as a GUI. It's a lot smarter. It is actually a full language. Okay, it's a full programming language. You can actually write games in LaTeX. Why would you do that? Computer scientists do this type of thing for fun, I guess. But you can't actually do that. So I actually have some of my documents actually have code in there so that I can compile it, and it'll adjust its behavior depending on the day or my need or an answer that I give it, which is really nice, which also means I can create a variable. And I can create a variable that does a thing, whatever that thing is that I need it to do. So for instance, in my document, I have an equation. It shows up 7 different times. I can create a variable that represents that equation, and I can just type that, because for me that's common. In the final document, you see the equation. But for you, you have a shortcut for this complicated expression that keeps showing up. So you don't have to go into the equation editor, go in the GUI. It's all done. It's all working. You can also do the same thing with a variable name. You can also do it with some kind of formatting feature that you have. So you can actually create these little commands that do these things for you. Not so hard, but we have those embedded where you can see those. So here's the first command that we have. New command. Pretty easy to figure out what that does. It creates a new command. The command name is first name, or author first. Okay? So that's the command, author first. Wherever I put in author first, it will replace that with Johnny. Okay? Some of you Americans may understand a little bit of Johnny be good, but it also dates me just a little bit. All right? This is 1950s. I wasn't there in the 1950s, by the way. I'm old, but not that old. So why would I want to do that? Well, the neat thing is that you're going to be prone to typos because you're human. And your first name only goes in the thesis in certain places. You don't really decide where your first name goes, because when you write your text, you're not going to refer to yourself by your first name. So why don't you just define it as a variable, and the template puts it in all the right places. So if I change that name, the name is changed in the template every place else. You cannot mistype your name. There's nothing more embarrassing than spelling your own name wrong. But when you have to type it a half dozen times, you're going to do it. Okay? You're going to be prone to it. That and a bunch of other things. So you can actually see that Johnny shows up right here in the title. And I'm going to move a couple of pages along here. Johnny shows up over here. Okay? And then, let's see. Johnny showed up over here where we went last name first. And it keeps showing up in other places. See if I can make this a little bit bigger. So that is nice. It seems kind of simple, but you have to remember that's one of many examples. Middle initial, get the middle initial right. Okay. There is indeed one thing you're going to see here that you're going to learn, and that is a tilde. When you type sentences into documents, there are rules in typesetting for what to do at the end of a sentence. What those rules are, why would you worry about those? Microsoft Word, though, doesn't really give you many options. Microsoft Word doesn't know that a period ends a sentence or not. So in this particular case, after that initial, you have a dot, and it's not the end of a sentence. The tilde means make it a regular space. That period is just another character. In the old days with typewriters, we used a double space after a period. I see a couple of people nodding. And then there's people that say you never should have done that. There's reasons, there's long arguments, etc. Set all those aside. Line breaks, you'd like them at the end of sentences. Not necessarily. If you have to stretch a line to make it justified, there's different places you want to put spacing. That's called kerning. There's an algorithm underneath here for kerning. And in fact, the person who wrote the kerning algorithms for this was hired by Adobe for the professional typesetting software to put it in there. It happened in LaTeX first. It was a dissertation. Why would he do it in here first? It's open source. And that's actually a little bit of a lesson. High-end technologies end up in open source first because they're basic research. People try it out, and they try it out like you are, anybody here doing research. You try it out where you can. You can't go inside some commercial code and change it. You can go into an open source code. Typically, the commercial code gives you friendliness. The open source gives you power. The question about whether you can access that power is a separate one. So you can see good, the last name. And then you see over here, new command, degree, and this is the full name of the degree, and here's the short name of the degree. And over here, you have these. What are those? That right there is, I will allow you to break the line here. Do you have to put this in all these things? No, this is a demonstration document. Okay, so we put a bunch of things in here. We use like every trick there is in the book. So somewhere in this document, you can find the trick you're trying to do. Right? This is the difference between this and the template that's already online at Overleaf. So this forces hyphenation at syllables if there's a line break that is required to make the document work. New command, degree short, thesis, dissertation. This is a dissertation. So every place where it says thesis or dissertation, it swaps out. Department. You know, a big problem I had is people complaining that we had the wrong name because they were not in mechanical and materials engineering. So I decided to make it wrong for everybody. So it's the Department of Lollipops. I thought lollipops make everybody happy. So it's Department of Lollipops. So wherever the department shows up, it'll be replaced by the correct department name. University, Wright State University. We could have hard typed that in there, but we did it this way, so if somebody at Purdue wants to copy the template, they can copy the template and they can use it. So that was just being a good net citizen. Right? And over here you can see some really great title that provides a concise view of the topic your thesis will address. You'll work on that, but we actually allowed it to break here. Why? Why not? We just showed that as another detail. Bachelor's degree short, BS, and we have this as ME, mechanical engineering is where this actually came from, didn't change that. Bachelor's institution. Not everybody graduated from Wright State University, so your undergraduate degree, you need to get that correct. So it says Universal University. And so these are the things you're going to have to go through. When did you get your bachelor degree? And this will make sure everything ends up in the right place and formatted perfectly to the university standards. Short paragraph, PDF subject of your title or focus of your thesis. Now the one thing is, you'll notice the right side is not following along with this, and this is because these are all variables that you can just edit and have them formatted correctly and put into place in multiple places. And there's a lot of difficulty in getting all that formatting correct in LaTeX, and having you go through and figure out how to do that was going to be messy, and even for us it's messy. One of the things we like to do with LaTeX is when you're writing the document, we want to think of it functionally. When you write a document in Word, you think about how it looks. And that's not the right way to think about a document. When you're writing a document, you want to think about what's the big picture, what are the sub-pictures, What are the sub pictures? And what's my verbose discussion on those issues? Title, chapter, section, subsection, text. So if you think functionally, you'll actually write better than if you think about how it looks. Oh, this should be bold now. Why? Why should it be bold? You have to think about that. It doesn't seem so hard. When you get into a 100-page document, some theses end up going 200 pages. Believe me, eventually it starts to fall apart in your brain. What level is this? How am I doing? Here, it ends up easy. So that's part of the reason it looks like this. When we get into the document itself, when you're not editing variables between the curly brackets, it gets a little easier. Now, PDF keywords. PDF keywords, this is so you can actually, in searches, you're going to create a PDF document. Those searches in those PDF documents can look for keywords when they search at the library. It knows to do that. So this is going to help with that. What are the key things in there? It may be human subjects, I don't know. I'm trying to come up with something biomed. I'm not even qualified, okay? Blood flow, I have no idea. But you can come up with some kinds of keywords for what you're doing and the year you're going to complete this. Now, unfortunately, right here, we're just going to ignore that right here, but it does indeed use this. What we're actually doing is we're allowing hyperlinks to work in your document. So when you create this PDF, it's hyperlinked. If you refer to a section, you click on it. It goes to the section. If you click on a link for an equation, it goes there. How about a reference? It goes there. Makes a really nice document. You don't have to think about it anymore. When you create an equation, you reference an equation, you don't have to say, and links to this place. You don't even think about it. It's all automatic. Right? Advisor's name, hopefully you get that one right. PhD, PE, get all these right. Thesis director, title. All right. When you do write your thesis, dissertation, signature sheet, get the business cards for everybody that's on your committee. They will make sure their business card is exactly how they like their professional name, and that's what it's going to look like on the signature sheet. If you have it wrong, it may be tough to get them to sign another sheet again, and it just makes people a little bit upset because the reality is my name, Joseph Slater, I'm not even the only Joseph Slater professor in Ohio, nevertheless the nation. I'm also not the only Dr. Slater in aerospace engineering in Ohio. So you need to get that right. Now some people will have very unique names and some won't, but the reality is get the professional name right. It really does matter. It's not a small detail. You can get it right and you don't have to worry about it again. Best way is, can I have your business card? Just get the business card. They will have it right there. Department offices will always have business cards. Okay. Program. You got to check all of these names. The program director is Dr. Ciarello still for this. And over here, you can see that's a typo. I forgot that I needed to put a, that's not the end of a sentence. I should put a tilde in there. Okay. Might have actually seen a change in there. It'll actually recompile. Let's change it back here. Right there. It'll actually recompile on this, but it often doesn't see much. It's often about the line breaks that changes these things. Yeah, can't see that one. That one's actually pretty tiny. Okay, so it did update back and forth, and you can see it actually updated in between. It took that space out. All right, there it is. Yeah, it's actually a little bit smaller now. It's kind of nuanced, but that's what gives it that professional typeset look. Okay, not always critical, but you can put those in there. I'm just going to edit this as I go along. That should have a tilde in there. PhD director or chair title, director, PhD in engineering program. So that is his title. It's going to be different if it's a thesis. It may have to be the chair. You're going to have to figure out what that is. I did actually correct this here, and that is the name of the current acting dean of the graduate school. Double check it though, could change. We had this problem in ME with some people graduating. They defended on the last day of Dr. Fife, but it was submitted and Dr. Fife wasn't there to sign the document. So what name do you put on? Committee members, how many are you going to have? You can add or delete these as you need them. Okay, if you don't need it, it goes away. This took me about a week to program. No, actually not really, but it took me a long time here. So it'll stretch and make these lines spread out nicely so you don't have to worry about the typesetting. All of that is just editing variables. That's all you're going to do. That's all you're going to do. Now, the bibliographic style is already set. How to change how your references are typeset, you can Google that and you have to look that up for what the expectations are. Why would I say that? Because I haven't typed a reference in 20 years. Why would I do that? The reality is references are in databases, and if it's a title, it's supposed to be in quotes or italics, and the volume is supposed to be bold, and it's supposed to have the last name of the first author, followed by a comma, followed by the first name. Why would I type this by hand when the database has all the information in it, and it can move it all around for me? So one thing that happens there is, and you can do this with EndNote or so on and so forth. There's other applications for do that, but this is out there in freeware. I use a database, and we'll show you that. So this is the line. There's notes in here to read on how to do this. Now we're actually getting into beginning the document. All right, this section, don't touch. Still don't touch. It can be exciting. Now, you can always delete this and get this template back again, but if you do it in yours, until you know what you're doing, you don't want to touch this stuff. And in fact, I wouldn't touch this stuff myself. I know exactly what it does. I'm going to do that if it's broken. If it's broken, best thing to do, email me. If it's actually literally broken, and I'm not going to be able to help you with your typesetting of all your documents, but if the template has an error, if the grad school says the spacing is wrong, tell me, I'll update it, and then everybody gets the updates. Send it back to me. All right, so hypergraph setup. This is the hyperlinking that gets all set up. We'll ignore that. Package WSU, Wright State University, formatting styles are all defined inside that document. You don't need to look. Page numbering, use Roman numbers. Page style, plain. There's a reason for that. Right header, today. And so we can actually put headers on here. You can actually figure out if you take that out, you're not going to have that header on there. Begin document. This is where you actually start working. Okay, begin document, this is where you write your document. Now, what we're going to do, the first thing we're going to do, and you're not going to change this, is make title. All those variables are used by the make title command. And I updated that make title command to do that, so that title creates all of this format for you. Well, the spacing is all taken care of. You don't have to say, well, 3 lines and all of this other stuff. It actually is spacing it out and stretching it to look spaced. If you have extra lines in your title, it'll make it nice and centered, beautiful. You don't even have to worry about that. Double space. Everybody likes a double space. That way we can mark it up in between and make corrections. Let's see. There's an approval sheet. Again, creates the signature page. Abstract. You can kind of ignore all of this yet again. You're not going to be touching much of this. Right? If you read it and you don't understand it, ignore it here. Begin, center, abstract. Now, one of the things you can do here is you go to your abstract, and if you notice here, what did I do? I essentially am right-clicking, position in preview, and it's finding the page. It'll synchronize it so that they match side by side. Okay? You can do that in both directions. I'm not as smooth in this. If I used it for a couple hours, I would be. I spent most of my time trying to get Panapto to work. Hopefully that's still recording. You still awake at home? All right. So that's where your abstract goes. Okay. And then over here you can see, here's the abstract. Now all of this stuff was created from those variables. Okay. All that was created from those variables. You don't have to do that. That's a required header. You don't have to type it. Did I get it right? Did you get your name right? I mean, this takes the work off. Here's your abstract. You can actually find the same text, and if you notice, see that finding position right there? So it's actually finding in the PDF where it is in your document, and it highlighted it blue for just a minute. Okay, and then we can go on. You may have to have a list of symbols. If you don't, you can actually delete this whole page. But you can see how we did this. How does this work? You don't have to know. But right here, we're going to talk through it a little bit in case you do. Over here, we just listed chapter 2, we use this. Chapter 3, we use this. If I want it large, I just tell it it's large. How do I know how big large is going to be? It's larger than normal, and it's ratios. And this is standards that are out there in the typesetting industry.
If I want it even larger, I would make the large with a capital L. That's the trick. So you can look up what all of those commands are. It's easy to Google that. Sizes of fonts in LaTeX. And you just go large, large, larger, okay, instead of choosing a font size. What that means is when you're going through your document and you're saying, all right, make this 11-point font. Oh, shoot, I was using 12-point font. Now I have to go back and fix all of that stuff. You're using the normal size. Somewhere else in the document, we define the normal size. The normal size for your document is defined in the style file, so you have the right size. So you don't think about that. If you want something large, you make it large. If you want it larger, you make it capital L. And I think big is another command. You know, they're not really all that fancy. Over here, this is how we make characters. Now, you could go through finding where to make, how to make a gamma in an equation editor in Word. But by the time you have gone in and clicked on those to make a gamma, I typed $/gamma$, and I have a gamma. All your Greek characters can be created with / Greek name of the character in the math mode. The $ put you in math mode. So inside those $, I can type equations. No equation editor necessary. Are there online or other tools for actually creating that with a GUI? Yeah, there are. It doesn't take you long to say, never mind. So some of you will start with those, and after a while you say, that's just a waste of time. I can type faster than that. In fact, what you'll find is because it's text, you can actually copy and paste it very, very quickly by dragging it. You recognize this equation over here, right? Quadratic equation. Okay, I just typed that out, and it's not hard to understand. Go into math mode, make a fraction. First parentheses is the top part, second is the bottom part. The nesting of the parentheses can make it a little bit challenging, a little bit ugly. Blank lines in LaTeX mean nothing. Blank lines, returns mean nothing. A blank line means a new paragraph, but to make it organized, you can hit return, and every set of parentheses, you can make it separate. Okay? So there are simple ways to make that neat and clean and organized. Again, since it compiles it as it goes, you can actually see if you type something wrong in the wrong place, because that'll show up over there in just a second. All right, now, plate length. You see that 4 over there showed up? You can see that it's wrong, so it's not too bad. You can have compilation errors, and it'll give you information on that as it goes. And in fact, if you notice this, you see that redness on there? That means, hey, you didn't close a bracket correctly. So it's nice enough to tell you that. Yes? No. Now that's actually a lie. But that just means I'm not going to cover it today. So you actually can. I would not get too excited about that. But if you're really into coding, yeah, you can.
It's really the simple thing, so you're not making any mistakes in the document.
Yeah, and you can. I just typically don't. I calculate it offline and put it in, because the reality is, most of the time you just don't really do. You just don't really need to do that. That said, what I do is I personally use Mathematica. You can do, or you can use Jupyter, which is a Python notebook. And you can actually typically take the equations and say, convert to LaTeX, copy, paste, and boom, it's in your document. So that's one way to do this. Another thing is if you're using MATLAB, Python, Octave, any of those, if you have a matrix, I have programs for that are online. You can find those easily enough. Google is a fantastic tool. And with one command, you can say, convert this to LaTeX, and you have the matrix, so I copy and paste it in. So whatever environment I'm in, I typically just write a script to make those and do those correctly. They're actually pretty easy. I'm surprised that I'm the one that came up with doing this. So you can do the calculations in here, but I don't know that I wouldn't make that my first choice. I would rather have a Mathematica notebook or a MATLAB notebook, or myself, I like Python. Python actually will typeset equations for you. I have other blog entries on how to do that, okay? All right, so we can go through, we use the tabular environment here, and what we did is we said make the first column point 0.75 inches. You can use cm, you can use points, you can use other units. You Google those and figure those out. And then make the other column left justified after that. Really doesn't matter what else I would say, because it's going to go as long as it needs to go. Chapter 3, we go on and we define these things. And you'll actually see a little bit of what Sean Mortar's thesis was, because his words and his equations are what survived, and I just added a few other things. But there's some examples of equations in there. All right. Table of contents. This is one of my favorite ones. Table of contents. How do you create a table of contents? You use a command, /. All commands in LaTeX, you start with a \. Table of contents. And that's where the table of contents will go. How does it know it goes in the table of contents? Anything that you name a chapter, a section, a subsection, a sub-subsection, etc. It goes in the table of contents. After the table of contents, you'll want a list of figures. And when you create a figure, it is in a figure environment. It gets numbered, and you just type list of figures, and there it goes. So as you update your document, these are done. Well, I got to make sure this shows up in my list of figures. It's done. If you create a figure, it creates it. List of tables. Create a list of tables. I had to create a table just so I could create a list of tables. Actually gives you an example of how to create a table. Probably the greatest criticism of LaTeX is tables are a pain in the butt. Yeah, that's right. You stopped yawning, so I'm impressed with that. So over here, you can kind of ignore this command here. This is in here, but that's actually setting a value of how far to indent the paragraph, and it's 2 em dashes, which is a typesetting rule, something that if you're an English lit major, you probably have a better idea what an em dash is. Some people might have learned this in class, but I'm guessing it's 2 or 3 people in this class. But anyway, that will actually get your indents right for all your paragraphs from here on out. And there we go. So we've set the indent size throughout the entire document. One thing you'll notice is you're not going to be fiddling with rulers in LaTeX. No graphical. You're going to define this is how much you should indent, and that's it. Okay. Another thing you might keep in mind, figure widths. If you've ever seen somebody with a Word document, how big do you want the figures? You probably want them all to be the same size, except the large one. So you define a variable for a large figure width and one for a regular figure width, and then you just decide when you put in the figure, I want it regular width. Oh, that doesn't look right. Well, change them all. Okay, but make them all the same. It's about consistency. And it's about not sitting there and fiddling with dials, trying to get all that stuff to work. Acknowledgements, descriptions on how to do acknowledgements. Dedication, I even put in some suggestions. If you're married and you don't thank your spouse, it's not going to go over well. All right, I'm just going to tell you. If you got a girlfriend, I mean, you have to gamble. Is she still going to be around? Boyfriend, same thing. But mom, you got to thank mom. Okay, Dad will be forgiving of that. Just buy him a beer. You'll be good. All right. In the beginning. All right, here we go. So we just start typing. Neat thing about these style files, you're not supposed to indent the first paragraph. It doesn't. The second one, it will. Why? I don't know. I didn't make up the style, but we don't have to worry about it. It's smart enough. It has that's built in. When I say built in, I programmed it in, so it did that. Citations. And just for fun, this is a ridiculously long section name, isn't it? But you might use a long section name. If you look in the table of contents, you'll notice we use a shorter one. What we did is in here, you'll actually see that I define a short section name in square brackets. This is going, well, let me rewind. This is going to be a section. Here's the short name for the table of contents. And here's the long name that I'm going to put in the document. Okay? And it turned out to be bold. Why? Because the style is it's supposed to be bold and perhaps a little bit larger. If the graduate school decides to change it, I'll change the style file and the whole document will be updated. Okay? We can go through, in this document we're using the ASME format for the citations, etc. This is probably the hardest thing for you to figure out in the document, but the comments in here explained how to change how you do citations, etc. But one thing you'll actually see over here is C section right here, See that's just one of those silly spaces here. It's probably not even necessary. But see that right there, sec equations? This right here is inside a label command. So watch this. I go over here. I can see section 1.2. Apparently it's not doing it inside my document. It'll do it in a regular PDF viewer. Let's go over here. We'll click on equations. So I click on equations in that section. Here it is. Right after that, I said label it. You're labeling it with a variable so you can reference it. And the point being that later on you can reference it, and if the name changes, doesn't matter. If the number changes, doesn't matter. It goes to that point in the document. It pulls out that name or whatnot. And you can actually do a page ref. So if you use the command page ref, it'll actually take the page number. So as the object, equation, figure, whatnot, moves in your document, it keeps updating that page to keep track of it. We've already gone over some of those other things here. We only have 9 minutes left. I'm taking a lot more time than normal, but I think I'm doing a better job. You can see other examples, how to do equations, etc. We already talked through those, so I can actually go through those a little bit. We have over here, though, if you look at this, you still see it is a little bit sometimes hard to read. That is one of the criticisms you can have. But over here, you see where I use the asterisk? That's for this equation here. I didn't want to make it in a numbered equation. Why? I don't know. You tell me. It's going to be your document. If you don't want to do that, you don't do it. But you can do that because sometimes you just want to pop something out. You know this equation, but we're not going to refer to it or whatnot. You just want to throw it out there. Otherwise, equation numbering is always done automatically. Chapter, point, number. Okay. And again, you can label the equation. No point labeling that. But here's an equation. It's labeled. And this one is labeled alpha over beta. How incredibly creative was that? Okay, but I labeled the equation so I can cite that equation later if that's one that I'm going to use a lot. So we go with the begin equation, end equation. Over here, I created aligned equations. You can see what they're aligned. They're actually aligned by the ampersands. You see the ampersands there? So it may be that you want to align them a little bit different. And with these equations, it's a little bit difficult to do it. But say I want to align the front of one equal sign with the back end of the other one. Well, it's going to do something really weird, right? So this equal sign is lined up with that equal sign. Okay, the front of that with the back of that. There's no good reason. And in fact, it's really that equal sign being lined up with that alpha there. I'll put that back because that's just really weird. Okay. Another thing here, same applies for. Sometimes you don't want it to look like regular old text. You want it to look like a command, or if it's a MATLAB command, or if it's some of you are using R, or some of you might be using Ruby, or Ruby on Rails, something like that. You can use the verbose command. Type it exactly like this. Sometimes it looks like there's commands inside there. You don't want them to show up as commands. Use the verb command. Any variables can actually, any characters can start and end, and here I used single quotes to do that, to start and to end. This is a translation thing that was kind of entertaining. I don't know why that happened. All right. Spaces, by the way, you see this typo with extra spaces. Well, you don't see them over here. Why? Why don't you see them? There we go. Because 1, 2, 3 spaces, it wraps them up. It says, look, it's one word, it's another word. 1 space, 2 space. So you're not going to see that weird gapping that you have. It precludes, it compensates for a lot of our sloppiness as humans, which is good. Here's how to make some matrices and some ugly equations. What's this equation mean? I don't know. I can't remember what it means at all. I have no idea. But here it is. I don't know if it means anything. And in fact, I'm pretty sure that those NNs shouldn't even be there. That's interesting. But you can see here how to make a subscript, go under. How to make a superscript, use a hat and go over. If there's more than one character, put it in brackets, holds it all together, so it's to the -1 power. Over here, we begin an array. This would look a heck of a lot easier to read if we put spaces in there, and we can do that just to make these things line up nice so it's easy to see what's in which column. So this is a little bit ugly, so I can clean it up. So you can see what goes in the first column of the matrix, what goes in the second column, what goes in the third column, so forth. Going to need more space here. And you're going to see that nothing is actually going to, it's going to retypeset the document because it's not that smart. But now it's a lot easier to read. And that's what I'm talking about. Spaces don't matter. Existence of one space, 100 spaces, it does the same thing. Some of you are going to go into Microsoft Word anyway after this talk, which is fine. Don't use spaces to move things around. It's just not the way to do it. It really doesn't work. Okay? It'll fight back against you. Why? Because Microsoft Word tries to use some typographical rules with you. Okay? It's not the right way. You got to use tabs or something else that's a little bit better. So, simple equation there. Some other things, not equal signs, and we can actually show some other things. This here, because there's a blank line, means it's a new paragraph. It has to be indented. If there's no blank line, there's not going to be an indent there. It's like magic here. I'm just waiting for the trick to show up. Never works when you're watching. There we go. See, it went away. So I can put that in there, and that means it's a new paragraph. Sometimes after an equation, you're still within the same paragraph. Sometimes you're not. How to do figures. Here we use, these are just comments, just makes it stand off nice when I'm reading it. And I can go over here, and I created a subdirectory named PIX, P-I-X. That's how hip I am, huh? I didn't use P-I-C-S, I used PIX. And you can see these are blue. In the PDF, in a PDF viewer, the hyperlinks will work. It seems not to work in this right now. I don't know what's going on. It's not really the goal. You're not going to send them, use Overleaf as the way to edit it. Okay. If you use Technoscope, it'll certainly work in there. Here's a few figures we have put in here, and I even use subfigures. And so sometimes you want to number these figures. This is one figure, figure 1.1, centered the caption. Here's figure 1.2. This is also centered. This one's just so short, it doesn't go end to end, so you don't really notice it, but it uses proper typographic rules. This is a problem you're going to actually find with your documents, is getting the font sizes correct in your figures. Good luck. I stopped using MATLAB because it's a beast to try to get it to come out at the same font and everything else. I use different things than that, and there's only so many things I'll promote in one presentation. But I use, it says on there, I use GNU Plot, or I use Matplotlib. There's other libraries for doing that plotting, because this does get frustrating. You go to Excel, it does the same thing. They tend to fight with you. Scientists, engineers, they wrote these things because they got tired of that. Okay? They're not trying to make high school reports. They're trying to make professional documents. These here, these figure labels, how do you make a figure? Begin a figure. This is forcing it to the top of the page. Why? Why not? Because we wanted to. We're going to center this figure. It doesn't have to be centered. We're going to include graphics. How wide do I want it? 3 inches. Now this 3 inches could be, in my manuscript, I'm writing a book, I have a variable fig width. So I would say width is equal to /fig width. That way I can tweak it, and it does it for the whole document. So that's something I probably should change in this, is to make it fig width. Okay? And here, the file it's looking at is example. And inside the subdirectory PIX is a file example.something. I don't know what it is, but LaTeX will convert a lot of those back and forth for you, and we put all those packages inside here, so it'll do that nicely for you. And here is the caption. And here's the label so I can reference it later. Subfigures. So sometimes you want 2 figures in here, figure A, figure B. Here's an example of how to do it. We're going to make a figure. We're going to center the whole figure. We're going to create a subfigure. Notice that it's just a command. Here's the caption for that first one, first subfigure right here. By analogy, we can put a label in it here. Include the graphics name, and it'll scale this. And I made it 0.45, and you asked about math, 0.45 times the width of the text. So right here I wanted the width to be 0.45 times the text width. So if you took this and you put it in a different document and the width changes, the figure will change sizes with you. Okay, so it's all scaled. If you change the margins, the text width is going to change as well. The figure will stay within those margins. You probably had this in Word, right, where the figures run over the sides or whatnot. This will just keep that scale nice and elastic and keep it coordinated. Like I said, don't think you're going to learn LaTeX today. You're going to get an idea and have a template that's full of all the tricks. Okay. More subfigures. There's a whole bunch of them all put together. And here I actually crammed them together, used another little trick. We're just going to leave it and set that off to the side. Including chapters or files. One of the neat things you can do is you can actually set this, you can set LaTeX, whoops, didn't go to the right place. You can set LaTeX to just bring in another file. Why would you want to do that? Well, sometimes you just want to edit a smaller file, just one chapter at a time, and you can do that. So you can use an include or an input, and over here, we have tables you brought in. We're running over here, so I'm going to have to kind of jump through. But here's how to do tables, and here's how to do code. If you look through at this, you'll actually see that that table is actually brought in from an external file so that we can edit it. We can actually bring in MATLAB code. And here's MATLAB code. There's a couple of different ways to do the formatting. Most of you, if you're using Word, what you're going to do is you're going to copy and paste it. And then you're going to edit your .m file. And then you're going to copy and paste it. Then you're going to edit your .m file because it wasn't working right. And then you're going to copy and paste it. After you do this about 100 times, you start to realize this is the pain. Well, the cool thing is, in LaTeX, I can just say, include that .m file right here, and put it in and format it. And that's what actually happens here. Using the listing command, I want it to be MATLAB. I'm using this style. I just brought in a style, and it actually is referencing that. And you can use a directory path structure to point to it. So when you update it, your thesis is updated with that listing in it. We're getting in trouble because the next class is coming. She's going to be really nice, though. She's very patient with me. So, more tips on this. This is less up to date than on the than online. There's another option here. Let's go through quickly, though. We can make this rich text looks a little bit different. You get some idea what this is going to look like. It'll actually show you the equations typeset as they go with the figures in there. So it makes it look a little bit more like the PDF as you're working. So that's a nice little option. I can go back to the project. One thing I did not have a chance to do is look at Zotero. You can have your bibliographic database, and this is actually all online in an application on my computer. You can have it import. This is readable. You can see it's just variables being defined in a format. Did I type this? Are you kidding me? Why would I type this? Zotero will export and put it in a proper format. In the future, though, you can read it because if there's a typo, you can edit it. You don't have to understand it, but you can edit this. No big deal. You know, I can put that in there. This is actually not editable because it's there, but you could download this and save it. Cool thing about Zotero is I can go out onto a website, Google Scholar, and it'll build that database for me with a plugin to Safari, Chrome, Firefox. Okay. So your lit searches just got really easy. Typesetting doesn't matter. I somehow skipped. We went through fast. In here where we have a reference to a paper, we just use cite and then a variable name for the paper. And then it adds it into your document. You might have 100 papers there, you cite 20 of them. Those are the ones that will show up in your bibliography. So you're going to build your own personal library that way. Might be giant, might be small. You create names for them that are usable for you. All right, I think that is about it for time here. I think that Dr. Fenley is about ready to burst in and throw us out. Thanks very much. If you have any questions, send them to me. I'll try to answer any questions you have.